Alright, so we're going to do kind of a little bit of a lecture here, so sorry if it's not as exciting as my normal commentary, but I'll do my best. So we're going to be talking about forces. Okay, so we've already done our information about motion, and now we're going to delve into, well, why do they move like this, and what is creating this type of motion, what's responsible for this type of motion, because force and motion are very much intertwined. So we're going to start with just the definition of force. Alright, if I can get my pen to work. And you need plenty of things set up, didn't you? Alright, so, force. Okay, now we are going to define a force as a single interaction between two different objects that results in a push or a pull. Okay, so that's the definition of force that we are going to be using. Okay, but what does that really mean? Okay, well, there's actually a ton in this definition, and so we're going to pull some stuff out. All right, so we're going to get a little more detailed here. So, all right, so when we have single interaction, that was supposed to be blue. Man, you know, you tried to make the blue better. Single interaction, there we go. Two different objects. Okay? So, what this tells us is that an object cannot apply, there we go, a force to itself. Okay? You cannot have an object apply a force to itself. So I know right now you're all like, but Mr. Szymanski, I can do the sound of one hand clapping, and you're going to do that. Okay, I get it. But one thing that we have to understand is that that was not your, because you do that sound of one hand clapping thing, you basically are not having your hand hit your hand. You are having your fingers hit your hand. So an object cannot apply a force to itself, but we can break down. Why can't I type today? Typing right. We can break up a single object into multiple objects. Alright, so we can break a single object into multiple objects. So again, your hand is an excellent example. The sound of one hand clapping, it's not a thing. But you can make it so your fingers are hitting your palm. Okay? You can't slap yourself in the face. That's not possible because you can't hit yourself. But you can have your hand hit your face. So again, I'm taking a bigger object in both the situations and breaking them up into multiple smaller objects. Okay? Now what this means between this idea of a singular action, we actually have built into this a beautiful thing called Newton's third law. Alright? Now you probably have been introduced to this because I'm finding out that my kids learned this in like grade school. And you learn Newton's laws, you don't really know what they mean. But Newton's third law is that law that states for every action there's an equal and opposite reaction. Well, I hate the way that's phrased because that's not the full story. Alright? Newton's third law, what it's really talking about is that when two objects interact, you only get one force. Okay? So two objects equals one force, but that force is viewed from two different points of view. Okay, so when two objects interact, no matter how big or how small they are interacting. They are creating one single interaction. Okay, one single force. So if a truck hits a bug, they applied the same force to each other. We think this can't be true because they're like, well, the bug go explodey, and the truck didn't even notice it hit a bug. All right, that's because the different forces acting on different things have different effects. Okay? I play a lot of football back in the days of yore, and basically, if someone hit me, I'm much bigger guy than most people are. So when they hit me, there was a different outcome. Okay, but we both walked away with bruises because we both had the exact same force applied to us. So when you push on something, it pushes back in the opposite direction. That's where this equal and opposite, that's where Newton's third law states, for every action, every force, there's an equal and opposite reaction. So it basically says for every force you apply, there's an equal and opposite force applied back to you. And so we really say, you know what, it's not like it's a different force. It's the same force, but you're viewing it from two different points of view. I pushed on you, you pushed on me. So I pushed right, you pushed left, that type of thing. All right? So that's a very important thing. It's just built into this definition. And then we have this last thing here, okay? We say that it results in a push or a pull. All right? But the thing you need to understand is a force doesn't automatically mean motion. Okay? And this actually has to do with Newton's first law. Alright? Now, Newton's first law states that an object, and this is again, you probably have this memorized, but object at rest stays at rest, object in motion stays in motion, and that's how much you know. One, that's silly because motion is motion and rest is just a specific type of motion that's zero. Okay, so I don't know why they would say restate this sentence. But if you have what we're going to learn are balanced forces acting on an object, then the object maintains its motion and it is basically going to keep its velocity. Okay, so if you're in a car, to keep going, you don't have to hit the gas pedal harder. Okay? But if you want to speed up or slow down, you do have to hit the gas pedal harder. If you lean against a wall, it doesn't mean the wall's going to move. Okay? It might not move. So some people think that to keep an object moving, you have to apply a force to it because we're used to air resistance and friction. And so if you want to keep running, you have to keep trying. But if you're in outer space, where there is no air resistance, no friction, I give you a push, you're just going to go forever. That's why the planet still moves and rotates. Nothing's forcing it to do that. Okay? So Newton's first law is again built into this because it has the idea that it does not necessarily, there is not an automatic link between pushing and pulling and motion. Okay, so we'll talk about first law a little bit, but I figure I'm here, I might as well just explain it. So, object at rest. Sorry. See, I was doing this and now I got into the whole, like, exactly what am I talking about. So I'm going to talk about the way I like to talk about it. So let's go back. Let's do black again. So Newton's first law, object in motion will stay in motion unless acted upon by an outside unbalanced. That's the worst they ever made force. Alright, so we'll talk about that a little more later on in the year. But notice how I just stay in motion. So if you are at rest, that's a velocity of 0. If you're moving at 30 miles an hour, that's a velocity of 30 miles an hour. So it's just a motion. Alright, so this is our definition of force. This is all the big stuff we're going to walk away with. Okay, so that's like step 1. Step 2 is just kind of going through the basic forces that we will be using in this course. Okay, so let's get some. Actually, just insert. There we go. All right, so now we're going to talk about the different types of forces that we're going to come across. Okay, so there are 4 forces that we're going to be focusing on, and they are going to be as follows. All right, so we have gravity. It's one we're all familiar with. It's why you fall. Let's say Batman, you fall to get back up. So force of gravity. All right, we go F subscript G, force of gravity, And this is a pull created by objects with mass. So any object has mass whatsoever, you, me, your pencil, okay, everything, that actually does create a gravitational pull. But I want to be very clear, it is in this level that we're going to talk about it as, is that it is only caused by an interaction with, put quotes here, planets. Because it could be like the moon, you know, it could be an asteroid. But so you'll get the, if you're living on Earth, it's almost always going to be between us and Earth. But you can like, oh, I did this on the moon. Okay, well that's different, and the moon's big enough to work. But you're not going to say, oh, it was me and my pencil, and it floated towards me. It doesn't do that. I mean, it does, but not if you can tell. All right, so that's the force of gravity. The next force that we are very much familiar with, well, let's just go down the color range, is friction. Now, friction is fascinating. I find friction one of the most interesting and misunderstood forces, because everyone's like, I know friction, I get that. But here, you gotta really watch how I'm gonna write this. Okay, so friction is defined as a force that resists the intended motion of an object. Alright, so this is very important thing, and the sub thing, it is also only parallel to a surface. Alright, it's only parallel, so parallel lines. Only parallel surface. The reason why I say it opposes the intended motion is because if you are trying to go one way, friction is going to stop that and then push back in the other way. Think of it like this. When you walk, think of it. You don't actually move your foot forward. You actually push back with your foot. And if there's friction there, which there pretty much is in every situation, then the floor actually then propels you forward because your foot does not slide backwards. But if you're on ice, you ever try to do a running sprint on ice, well, you push back and ice does not really push back very hard, so you just fall on your face. All right? So friction actually is what makes you move forward. People often think friction only slows down. No, friction can also speed up. It's why cars work on the road and they don't work on ice, because friction is what makes cars move. All right? So friction is a very fascinating thing. We have two other forces, and so that is tension. All right, F of T. And this is a pull only in any direction. Alright, so it's only a pull. You cannot push with tension. It's usually caused by cables and ropes and, you know, just grabbing someone by the arm and pulling on them. Okay, so tension's pretty basic, pretty straightforward. And then the final one is a normal force. Alright, so we call it a force normal. Now this is the one students often get a little confused because like, what's normal? Alright, well let's talk about what normal is. Okay, so one, it is a push only. That is perpendicular to the surface. Alright, so it is always perpendicular to the surface. And the term normal, okay, normal in math means right angle to. Alright, that's what the word normal means. It means right angle to. So if you've got the ground, that's why I like this symbol for perpendicular. If you've got the ground going left and right, the force has to be up and down. Okay? So it can only be a push, and it has to be perpendicular to the surface. So this is all the definition that we need to understand about forces, and these are the types of forces we're working with. So next time we talk about how do we actually apply this to new scenarios, and we talk about something called force diagrams. So hope that was exciting as it always is, you know, taking notes. But as always, Just do your best.